Hello, my name is Michael Shea from the Math Center at Grantham, and welcome to this frequently asked question video on slope of a line. This is part of a series of videos about commonly asked questions in the Math Tutor Center, or the Math Center. First of all, I want to let you know that this particular video will be appropriate for a number of courses: algebra, pre-calculus, finite mathematics, any of the courses that deal with lines and linear equations. And what I recommend you do is start with your text and read about slope in your text. Come by, watch the video, and then go back and look at your test again and do the problems. And hopefully that kind of back and forth and looking at it in several ways, a couple ways, will actually help you solidify the concept of slope in your mind. All right, so slope is what we're talking about, the slope of a line. First thing we're going to do is kind of just talk a little bit about a slope of a line. Slope basically means how steep a line is. So we see two lines on this graph. One is obviously a little bit steeper than the other one, okay? And but also we notice that there's another character of these lines. As you go from left to right, our red line, line 1, rises in the y direction, and that's said to have a positive slope. And line 2 declines or decreases in the x and y direction, so it's said to have a negative slope. So let's go straight now to the definition of slope, the mathematical definition of slope. This mathematical definition is in two parts, and I'm going to kind of talk about the two parts separately and try to show you how they kind of connect together and give you two different ways of looking at slope. So first of all, m is the variable normally denoting slope, and the first part of the definition is that it's delta y all over delta x. Okay, a little bit. We'll talk a little bit here about what delta means. Delta is simply a Greek letter that's put in front of the variable. It means change of. So you could read this as m equals delta y over delta x, or m equals change in y over change of x. Now, delta y and delta x are variables, all right? And I don't want you to be confused, because some people see this delta symbol in front of the y and think that like it's two different things, maybe multiplied together. Not in this case. Normally when there's two symbols in algebra together, there's an implied multiplication. In this particular case, this is just a way to create a new variable that emphasizes this is a change in the y variable and a change in the x variable. But both of these are individual single variables. Now, sometimes you hear a kind of a common sense English definition of slope as the rise over the run. All right, so and so let's just talk in the graph just a little bit in general. What we mean by delta y is that, okay, if I've got if as the line goes from left to right, if I pick two different points, the delta y is how far I have to go up in the y direction or down in the y direction. The delta x is how far I have to go in the x direction. We'll look at this in much more detail here in just a second. So I'm going to label this with a little yellow, that this is kind of the first part of the definition. And I'm going to give you the second part of the definition also, that slope is equal to y2 minus y1 all over x2 minus x1. Now, and we'll call this the second part of the definition. Now, I'm going to first talk about the first definition, and I'm going to then relate these two. Then I'm going to talk about the second part of this definition, I should say, and then we'll relate the two. And we're going to start working with line 1. So I'm going to go ahead here and pick a red color. Now, you notice here on my graph paper I have grid squares laid out every unit. And this this makes me, it's just kind of making this problem of counting rise and run or delta y and delta x a little bit easier for us. So it looks as if, and this line right here, line 1, it looks as if the line goes through this little intersection point of the grids right there. So I'm going to put a point right there. And I want to give it a name. So P is a good name for a point. But I'm going to have more than one point. So I'm going to put a little sub 1 here just to say, okay, this is point 1. This is what I'm calling point 1 right now. All right, and it's just called P sub 1. And so now to try to find our slope, I'm going to try to find another place where this intersects the graph. Now, not all of your lines are going to be so clean and intersecting, unit grid squares. So this is just done, for conceptual purposes. Once you kind of have the algebra down, you could deal with pretty much any situation. All right, so I'm going to pick this point right here and call that point 2. All right, so now what I'm going to do is, using the red over here to keep us consistent, I'm going to try to calculate or graphically determine really the slope of line 1. All right, I'm going to call it just m sub 1 just to characterize. Of course, the red color kind of does that for us too. All right, so that's going to be equal to, again, it's equal to delta y all over delta x, change in y over change in x. So my goal is I want to think of it as traveling from P1 to P2, but we're in a city, let's say, that all the streets run either north or south or east or west in these parallel grids, so you can't go straight from P1 to P2. You got to go either straight up and down or straight left and right. So first, how much do I have to change in the y direction? Well, I have to go up here 1 unit and 2 units up. All right. Now up is defined as the positive direction. You can see this on the x-axis here, on the x and y-axis. You can see that the positive numbers go up. You're going negative when you go down. So I'm going to come over here and put in that delta y is equal to 2. And then to get from this point here over to P2, I have to go 1 unit to the right, which is again a positive move. So it's 2 over 1, which just equals 2. So the slope of this line appears to be 2. All right. Now, just to show you, it doesn't matter which 2 points I pick. I just picked a couple of points here at random. But I could have picked any points I wanted to do this. And to show you this, I'm going to come up here and I'm going to pick this point 3. I'm going to pick this point that appears to be an intersection, and that's point 3. So I'm going to calculate the slope again, and I better get the same answer, right? Because it's the same line, and a line only has one slope. So as I think about going from P1 to P3, but having to go either north or south or east or west, I go 1, 2, 3, 4 up, and 1, 2 over. So I have a change of y of 4, a change of x is 2, and that's also equal to 2. So we're good. We're good to go. Now, I'm going to also show you that notice I picked points where the x-coordinate, we're going kind of left to right in terms of the x-coordinate. But that doesn't matter either. But it's very important when you're doing your movements to pay attention to the sign, the plus or minus sign of the movement. Because up is plus, down is minus, right is plus, left is minus. So let's take this, calculate it again. In this case, I'm going from P3 to P1. All right. So again, I'm looking at delta y over delta x. All right. So if I'm starting at P3 but having to go along the street grids, well, in this case, I'm going to have to go down. All right. So I'm going down 1 here, and we're going to say that's minus 1, minus 2, minus 3, minus 4. So my delta y is minus 4. Now to get back over to P, I have to go to the left. And I have to go to the left -1, -2 units, minus B in the left direction. So my delta y or delta x is -2. So minus divided into a minus is a plus, of course. So it doesn't matter which direction I go there, we kind of get the right answer. All right, so let's try this same thing in terms of definition 2. Okay, so in order to do that, I need the coordinates. Okay, now first of all, I want to talk about this definition here, this definition 2, or the second part of the definition. You notice I have like a P1 and a P2 over here, and you have to recognize that this slope definition here, right? This is defining a pattern, okay, and not any specific problem. So when I was creating these points, I decided I wanted to call this P1, and I decided I wanted to call this P2. But that 1 and 2 over there, P1 and P2, have nothing to do with the 1s and 2s over here in the slope definition. What this really says, sometimes it's good to try to translate these things in English. What this says is, okay, in this particular scenario, you're picking 2 points and you're saying, okay, the y coordinate of the second point minus the y coordinate of the first point, that's our delta y. That's our change in y. All right? Similarly, the x-coordinate of the second point minus the x-coordinate of the first point. So first of all, let's figure out what the coordinates of these points are. Out here to the right a little bit, I'm going to define P1. Not define it, but actually pull it off the chart. Remember now, for the coordinates of a point, it's the x-coordinate first. And if you look at the x-coordinate, it looks like it's 1. And the y-coordinate is 4. P2 has an x-coordinate of 2 and a y-coordinate of 6. And P3 has an x-coordinate of 3 and a y-coordinate of 8. All right, so using definition 2, we'll do it the simple way first, maybe. We're going to say, but what you have to keep track in your mind and do it as a little scratch paper to the side or penciled off to the side. What am I going to call my first point? What am I calling my second point? Now, what I'm talking about now is in terms of this definition up here. What's going to be the point you're traveling from and the point you're traveling to? The point you're traveling from is has coordinates x1, y1. The point you're traveling to is x2, y2. So I'm going to make just to make it clear, I'm going to call it my first point is going to be P1, and my second point is going to be P2 for this next calculation. Okay, and now this calculation should come out the same as what we have over here because we're still looking for the slope of M1. We're just doing it a different way. We're taking y2 minus y1 all over x2 minus x1. All right, so looking at this, I'm saying, okay, my first point is P1. Remember, this 1 and this 2 have nothing to do with that 1 and that 2, so you have to think about this stuff. All right, my first point is P1, so I'm going to look at, and my second point is P2, so to do the numerator, I have to say, okay, I need the y-coordinate of my second point. I go over here, my second point is P2, right? My y-coordinate is 6. So that becomes 6 minus the y-coordinate of my first point. My first point is P1. My y-coordinate of P1 is 4. So 6 minus 4, right, divided by, and then the x-coordinate of my second point, I define my second point as P2, right, and the the x-coordinate of P2 is 2, then minus the x-coordinate of point 1, or my first point, I should say, the x-coordinate of my first point. My first point is P1, and over here I have 1. So I do the math on this. 6 minus 4 is 2. 2 minus 1 is 1. 2 over 1 equals 2. I get the same thing. And hopefully it's clear now that x2 minus x1 is just a geometric way, right? Or excuse me, an algebraic way of understanding the way we kind of did it geometrically in definition 1 by saying we went up 2 and over 4. Well, you can calculate that simply by using the coordinates. Now I'm going to throw you something of a curve. Okay, I'm going to say that the first point, I'm going to do this calculation again, and again it should come out exactly the same. But in my consideration, my first point, the point I'm traveling from, I'm going to call it P3. And then my second point, P1. Right? Again, we have to just get away from the fact that these subscripts have nothing to do with these numbers up here. So when I go to calculate the slope, and notice how I write everything over again, that you might seem redundant, but it never hurts to write these things over again to make sure it's clear in your mind what steps you've gone through. So remember, this y2 means my destination point. The y-coordinate of my destination point, or my second point. Oh, that's P1 in this case. So y sub 2 is the y-coordinate of P1. That's equal to 4. And then you're going to subtract, okay, the y-coordinate of your first point, which in this case it's P3. So I'm going to subtract, oh, you know what? Yeah, subtract 8. Okay. And that's going to be all over. Now you notice you're going to get a negative in the numerator. Is that going to be a problem? Well, let's see. In the next step here, we have the x-coordinate of my, oops, anybody notice my mistake here? I put x2 minus x2, which would be, of course, 0, which is not what we want. We wanted an x1 there. Okay, so the x-coordinate of my second point is P1. My x-coordinate is 1, so that's 1 minus x of 1, or the x-coordinate of my first point, which in this case is, what I've labeled point 3, and that is 3. So we end up with minus 4 over minus 2, and minus divided by minus is a plus, so we get a plus 2. So no problems, right? No problems whatsoever. The different definitions we've looked at kind of geometrically with the delta y over delta x notation. We've looked at it algebraically, and you just have to keep track of what point you're going from, what point are you traveling to determine what x sub 1 y sub 1 is and what x sub 2 y sub 2 is. All depends on what you define as your source and destination points. All right, let's go ahead and switch over to the blue color and very quickly do this line here. Okay, this will be just a little bit different. I'm going to pick this point as my first point. All right, and this point as my second point, and I'll call this Q and P. See, it doesn't matter. I don't have to use the subscripts. Okay. All right. So for this slope of line 2, we'll do it via definition the first part of the definition for the slope of line 2 here in blue. We're going to look at the delta y over the delta x. All right. The delta y, well, okay, to go from Q to P, this is what I'm defining as going from Q to P, I have to go a 1, 2 in the negative direction. So that's -1, -2, negative direction, -2. And then I have to go in the positive direction. I have to go 1, 2, 3, 4, 5, 6, 7, 8. So -2 over 8 equals -1/4. Notice that I can take out that negative sign and put it in front of the whole fraction. It doesn't matter if that negative sign is in the numerator, in the denominator, or out in front. As long as there's only one negative sign in there, it all means the same thing. All right. Now let's do this backwards. Let's do this. Let's do it with the coordinate method. All right. So first of all, P's coordinates is going to be, well, x is equal to 4 and y is equal to -4. And over here, Q, we have x is equal to -4, y equals -2. So we're going to pick P as our first point. And Q as our second point. Little hand fatigue here. I'm getting a little sloppy with my writing. I should work on that. So let's take a look at this. M2, and now we're going to use definition 2, or the second part of the definition. It's y2 minus y1 all over x2 minus x1. All right, so I've got to keep this little note over here so I don't get it mixed up. Okay, y sub 2 means the y coordinate of my second point. All right, that second point is Q. The y coordinate is -2. So I have -2. Now the formula says I have to do a subtraction, so I'll do that. All right, and then I need y sub 1. Y sub 1 is the y coordinate of my first point. My first point is P. And my y coordinate of P is, be careful here, folks, it's -4. Notice I'm putting the -4 in parentheses, right? Right? To emphasize that, well, that to kind of separate out. You put two minuses together, it's a little bit confusing about what it means. So this is -2 minus a -4 in the numerator. We'll finish that a little bit later. Let's look at x2. x2 is the x coordinate of my second point. My second point is Q. My x coordinate is -4. -4, and then minus, all right? All right, this minus comes from right here, and then I have to look at x1, which is the x coordinate of my first point, which is P. My x coordinate of my first P is 4. And so that equals 2. All right, so remember, in the numerator, I'm going to just copy over -2. When you see a minus in front of something in parentheses, it's the same thing as -1 times that thing in parentheses. And since a minus times a minus is a plus, that becomes -2 plus 4. And down here, we can go ahead and solve that, reduce that all the way down. 2 minus 4 is -8. -4 subtract 4 is -8. And then in the numerator, we've got -2 plus a +4. That's going to be a +2 all over a -8. And just like we did up here, right? We can bring that minus out in front since we only have one of them. And then we reduce the fraction and we get 1/4 minus 1/4. So I hope this helps clarify the notion of slope. There's one other thing I wanted to point out here. And give me a second to pop another little program or another little graph in here. Okay, same graph I have before, but I've got in here a horizontal line L sub h and a vertical line L sub v. Okay, let's talk a little bit about the slope of these two lines. Okay, so if oops, got to go back to this and make sure I got the white color. All right, so for the slope of h, all right, is equal to delta y all over delta x. Okay, now y doesn't change at all, does it? When you have uh, uh, a completely horizontal line, okay, the y value doesn't change at all. So delta y equals 0. Now delta x doesn't matter which 2 points I pick here on this line. Let's pick black here real quick. I could pick these 2 points and delta y would be 2. All right. Or I could pick this point and this point, and it would be 1, 2, 3, 4. See, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. But doesn't matter what number I pick for delta y. I got 0 in the denominator. Excuse me, 0 in the numerator. So no matter what I pick here, all right. Oops, I got black selected still, and it won't write on a black background. My delta x, doesn't matter what my delta x is, my slope's going to be 0. So a horizontal line always has a slope equals 0. The slope of your vertical line, all right, again is delta y all over delta x. All right. Now in this case, y doesn't change. The y coordinate changes. The x coordinate doesn't change at all. Okay. Delta, that means delta x is always 0. All right, so you immediately see a problem here. If delta x is 0, it doesn't matter how many units I go on the y direction. I'm dividing by 0, and as we all know, division by 0 is undefined. So there is no slope of a vertical line. It's at least mathematically, it's undefined. It's sometimes characterized as being an infinite slope, and there can be arguments back and forth about whether you think of that slope as infinite or undefined. But mathematically, in terms of this algebra, it's undefined. I hope this little presentation has given you some insight into the nature of slopes of linear equations. And if you have any concerns or questions, you can go back to the Math Center and drop a question in the drop box or send an email to mathcenter@grantham.edu. Thank you so much. Have yourself a wonderful semester.